Picture this. You are standing on the deck of a modern guided missile destroyer. It is a masterpiece of engineering. You have radar that can spot a seagull 200 miles away. You have satellites, lasers, interceptors. You feel invincible. But then, a sensor deep below the hull chirps. Just once.
And that is the moment your heart stops. Because that chirp means the one thing your radar couldn't see is already moving at 50 knots, and it is coming right for you.
It feels counterintuitive, doesn't it? We have mapped the surface of Mars better than we have our own ocean floors. We have mastered the sky, but the moment you dip below the waterline, the rules of the game change completely.
Completely. Above the water, you are fighting with light and electromagnetic waves. Below the water, you are fighting against physics itself. It is the loneliest feeling in the world because in that environment, your billion-dollar eyes are useless.
That's what we are digging into today. The engineering of underwater survival. How do you stop a bullet when you can't see it, you can't outrun it, and the environment is actively hiding it? Let's start with the blindness. Why can't we just use cameras or radar underwater?
It comes down to attenuation. Light is absorbed by water incredibly fast. Even with the strongest spotlight, you're seeing a few hundred meters tops. Radar, it bounces right off the surface like a stone skipping on a pond. So, if you're a submarine commander or a surface ship, you have to rely on the only thing that travels well through water, sound.
Right, Sonar. And I think everyone has that movie scene in their head. The submarine captain leans in, tensions are high, and then ping.
The famous ping, that is active sonar. And yes, it works. You shout into the void, the sound hits a metal object, and it bounces back to tell you where the enemy is. But here's the problem with active sonar. It is suicide.
Suicide? That's a strong word.
Think about it. If you and I are in a pitch-black warehouse and I have a flashlight, I can turn it on to find you. But the second I do, everyone else in that warehouse knows exactly where I am. Pinging is like screaming in a dark room. You might find the target, but you have just announced your exact coordinates to every predator within 50 miles.
So, if screaming gets you killed, you have to listen.
Exactly. Passive sonar. This is the true art of naval warfare. It's not about sending energy out. It's about analyzing the energy coming in.
But ships are loud, aren't they? Engines, pumps, propellers. If you are trying to listen for a faint whisper of a torpedo while sitting on top of a massive diesel engine, isn't that impossible?
It would be, which is why we don't keep the ears on the ship. We drag them. Modern warships use what's called a towed array. Imagine a cable, sometimes a mile long, trailing behind the ship deep underwater. It's packed with hydrophones, underwater microphones.
A mile long?
You have to get the sensors away from your own self-noise. By towing the array that far back, you leave your own engine noise behind. You're in the clean, quiet water. Now you can hear the distinct acoustic signature of a torpedo's propeller, or even the flow of water over its fins.
Okay, so we are trailing this long tail, listening to the ocean. And suddenly, the operator hears it. A high-pitched whine increasing in frequency. A torpedo is in the water.
And this is where the nightmare begins. Because modern torpedoes aren't just dumb bullets anymore. In the old days, you pointed them, fired them, and hoped. Now, they are robots. They are autonomous drones with their own brains.
That is a terrifying thought. So, the torpedo has its own sonar?
It does. It has a transducer in the nose. It is listening for you. It locks onto the specific frequency of your drive shaft. It's called acoustic homing. But it gets worse. Some of the most advanced torpedoes don't even listen for sound. They are wake homers.
Wake homers? Like the wake behind the boat?
Precisely. A ship moving through the ocean leaves a massive scar of turbulence and bubbles that lingers for minutes. A wake. Homing torpedo doesn't care about your engine noise. It scans for that turbulence. Once it hits the wake, it zigzags back and forth inside that disturbed water, climbing up the ladder until it hits the source, your propellers.
That sounds incredibly difficult to dodge. You can't exactly stop leaving a wake, and you definitely can't outrun a torpedo doing 50 or 60 knots.
You cannot outrun it. That is the golden rule. If you try to run, you will just die tired. You have to outsmart it. You have to deceive the machine.
This brings us to the concept of soft kill. I love this term because it sounds gentle, but it's actually about high-stakes psychological warfare against a robot.
It is electronic gaslighting. The most common tool is an acoustic decoy, often called a nixie. It's a device towed behind the ship that generates noise. But not just any noise. It mimics the ship's acoustic signature, but louder, more attractive.
So it's a ventriloquist act. The ship throws its voice over there hoping the torpedo attacks the dummy.
Exactly. You want the torpedo's logic board to look at the two targets and say that loud, juicy signal over there must be the ship. If it works, the torpedo blows up the cheap decoy and you sail away.
But what if the torpedo is too smart? What if it realizes it's being tricked?
Then you escalate. You move to acoustic device countermeasures, or ADCs. These are small canisters you launch from the ship. They hit the water and create a massive, dense cloud of bubbles.
Bubbles. You are telling me we defend a billion-dollar warship with bubbles?
It sounds ridiculous, I know, but to a sonar pulse, a wall of bubbles is like a brick wall. Sound travels through water at a specific speed. When it hits air, even tiny bubbles, the density change is so drastic that the sound scatters completely. It blinds the torpedo. It creates an acoustic smokescreen. The torpedo literally loses sight of the world.
That is fascinating. It's using the medium against the weapon. But let's play out the worst-case scenario. The decoy failed, the bubble curtain failed, the torpedo is still coming, and it's 10 seconds out. What is left?
Now you leave soft kill and go to hard kill. This is the brute force approach. We are talking about anti-torpedo torpedoes.
A bullet hitting a bullet.
Underwater. In 3 dimensions, while both objects are moving at highway speeds. The engineering required to do this is mind-bending. You launch a small interceptor that has to locate the incoming threat, calculate its trajectory, and physically collide with it, or get close enough to detonate milliseconds before impact.
It feels like the margin for error there is practically zero.
It is 0. If you are at the hard kill stage, you are playing the final card in the deck.
This entire dynamic, the hiding, the listening, the decoys, it feels like a very slow, tense chess match, followed by a few seconds of absolute chaos.
That is accurate. But looking forward, the tempo is about to change. We are entering an era where the speed of these engagements will surpass human reaction time.
You're talking about AI?
AI and propulsion physics. We are seeing research into supercavitation. Imagine a torpedo that ejects gas through its nose to encase itself in a bubble of air. It's no longer touching the water, so friction almost vanishes. We are talking about speeds of 200 knots or more.
200 knots underwater? That's barely enough time to blink, let alone deploy a decoy.
Exactly. At that speed, a human commander cannot look at a screen, analyze the threat, and press a button. It's too slow. The ship's AI will have to detect the launch, classify it, and deploy countermeasures automatically. The future of underwater warfare isn't sailor against sailor, it's algorithm against algorithm.
Which raises a philosophical question. If the machines are fighting the battle at speeds we can't comprehend, are we just passengers on our own ships?
In a way, yes. We build the systems, we set the parameters, but when the water starts boiling, the math takes over. The ocean has always been a place where humans are intruders. We are just building faster and smarter ways to survive being where we don't belong.
That is a humbling thought. We conquer the surface, we conquer the air, but the deep ocean forces us to admit that we are just guests, and vulnerable ones at that.
And the rent is due every time that sensor chirps.
A fascinating look into the engineering of the deep. We've gone from listening with our ears to algorithms fighting in a bubble of air. It makes you look at the ocean a little differently.
It certainly makes you appreciate dry land.
Indeed. That's all the time we have for this deep dive. We've peeled back the layers of sonar, deception, and survival physics.
Thanks for having me.
And for everyone listening, next time you look out at a calm blue sea, just remember, there is a whole other world of cat and mouse happening just below the surface. Until next time.